Our sixth exercise, how many one-to-one this time functions are there from a set with 5 elements to a set with 8 elements. Let's do a quick reminder about the functions. I have again a function here, and the domain of the function has 1, 2, 3, 4, 5 elements. Here are their numbers, 1, 2, 3, 4, 5. And then for the codomain of the function, I have 8 elements, 1, 2, 3, 4, 5, 6, 7, 8. Let's begin now with element 1. This element must be associated with one of the elements of B, and I can associate it with whichever I like. So for element 1, there are 8 available options. So going to the second element, I want you to think, as the definition said, about tasks. I have finished my first task, it was the element 1, and now I am going to my second task. Now see that whatever element had the first element chosen, then the second element can be associated with any of the other elements except for the first one. So the second can go to any of these 7 elements, but it cannot go to the element that was picked by the first element of set A. So there are 7 picks, and I want you to confirm the rule of thumb that there was in the rule of product. For each selection for the first element, there are exactly 7 options for the second element. And this is really crucial to understand. This is where sometimes mistakes are made when applying the rule of product. The same thing exactly stands for the third element now. It has 6 options for association with an element of set B. And for the fourth element, we have 5 options. And for the fifth element, we have 4 options. So my typical solution is just that by the rule of product, there are, as you can see again, the solution is just one line, okay? But our thoughts are complicated. So the solutions are 8 times 7 times 6 times 5 times 4. Let's go to the second part now. How many one-to-one functions again are there from a set with n elements to a set with m elements? So again, let's write down some thoughts. We have set A, we have set B, and I forgot to write here that m should be greater than or equal n. So if I pick the first element of set A, it can be associated with any of the elements of set B. They are m in total. So the first is m. For the first element, there are m options. If I pick the second element of A, there are again m minus 1, because A has already picked one of them. So I can't associate the second element with this. I can associate it with any other except the element that was picked by the first element of set A. So the next one is m minus 1, the next is m minus 2, etc. Up to what? A logical thought is m minus n, but if we apply that to the first example, we'll see that this is wrong, because 8 minus 5 equals 3. So the last position should be 3 here, and I'll fix it by just adding 1 at the end. Then my typical solution is by the rule of product. The result is the following.